Hi, I'm Nikki. I'm the founder of Nicola Wilkin Limited, and I want to talk to you today about how we can look at the range function, which is an area that a lot of teachers have trouble with. But first of all, I just want to introduce myself. You may have come across me as Nicola Lacey. I've written quite a popular book called Python by Example that a lot of teachers are using in their schools. It gives lots of examples of Python programs that they can try out. I'm also one of the biggest sellers on TESS. I've also written for BBC Bitesize as well as Cambridge University Press. And currently I'm also working with Oak National Academy as the only reviewer for their new computing resources for primary and secondary that are coming out in 2025. So I do have quite a lot of experience with teaching Python, and I used to be a computer science teacher myself and head of department, so I do know the challenges that go on in a classroom. I also want to quickly mention Jump 123, which is a new pedagogy and way of assessing programming in the classroom. So you might want to check out my other website, jump123.co.uk, to find out a bit more about a new way of teaching it, which might be of use. So let's have a look at that tricky range function. And a lot of teachers struggle with explaining the range function to their students and why it stops before it gets that specified number. So let's have a look at that range function in practice so you know what I'm talking about. So here I have a for loop using the range function, and it's quite often used in a for loop like this. So we have for count in range 1 to 6, print count. And what we might expect from this is that the output would be 1, 2, 3, 4, 5, 6. So let's run it and see what happens. And you can see the output is 1, 2, 3, 4, 5, and it's not including the 6. And that's what throws an awful lot of people about this range function. So let's see what's actually happening and a good reason for why that's happening. So as we've seen, it's not really working as people would expect. I've trained people all over the country in how to teach Python a bit better, and I've heard all sorts of excuses from teachers about why the range function isn't working as they expect, such as it's just one of those weird things that Python does, or you just have to remember to add 1 on if you want the final number included. Neither of these are satisfactory explanations for students about why it's not working as they might expect. And there's a much simpler explanation, but it just takes a little time for people to understand it, and that's what this video is about. So let's have a look at what's actually happening. So here we have very similar for loop with a range statement, which is just a slightly expanded one. So we've got 0, 15 and 4 in the options here. So let's have a look at what's actually happening. So we have the count variable. That variable name could be whatever we wanted. We're just using it to have a placeholder and then print whatever that value is, where it is in that loop. The range statement is what we're actually looking at in this lesson. And so if we have a look at the example where we've got 3 items in the brackets, then what's that specifying to Python is the start, the end and the step count. Now the start is where the loop is going to start, so it starts at 0. The end is the target it's aiming for, so 15 or above, and then the step count is going up in 4s. So the output in this one would be 0, 4, 8, 12. Because once it reaches over 15, it's going to stop, which would be the next one, 16, which is why that's not included in the output. So that's if you've got 3 items in that range bracket. If you've only got 2, then it has to make an assumption. So the start and the end are what you're specifying when you only have 2, and it's just assuming that the step count is a 1. So it's going up in 1, so this would be 2, 3, 4, not including the 5. We'll explain why in a moment. If you only have 1 number in there, then that's just the end that you're aiming for rather than the start. So it'll assume you're starting from 0 and you're going up in 1s. So it's assuming the start and the step count when you've just got the end number in there. So this would be 0, 1, 2, 3, 4. So we can see that when we've got the range statement, we only need to include 1 number if we wanted to, but you could have up to 3 numbers in there, and they all specify slightly different things: the start, the end and the step count. So let's see how it's actually working. And it's a good idea when you're explaining this to students to use a flow chart. So here we are starting with the start symbol, and then we've got count equals 0. We've got a decision diamond to say if count is greater or equal to 15, and then if it is less than 15 in this case, so it's not greater or equal to 15, then we're outputting the count, and then we're adding 4 onto the count. However, if it is over 15 or equal to 15, then it'll stop the loop. So that's the flow chart that we're actually including here. In our flow chart, we've got the starting value, which is 0. We've got our target, which is greater or equal to 15. And it's important you've got the greater or equal to in there. And we've got our step count, which is plus 4 each time. And we are going to use this trace table to show what's actually happening as we work through this flow chart. So first of all, we start, and then count equals 0. So our count variable in our trace table becomes 0. And then we go down and check, is the count variable greater or equal to 15? It's not, it's 0 at the moment. So we can continue with the no, and we're outputting count, which is 0. And then it goes on to the step, which is adding 4 to it. So count is now changed to 4. And it's at that stage that it loops round and checks to see if it is greater or equal to the target, which is 15. Is it greater or equal to the target? No, it's not. It's 4. So it goes to output 4. Then it adds the step count, which is making count into 8. And then checks the decision diamond. So is count greater or equal to 15? No, it's not. Count is only 8. So we output count, which is 8. We add 4 on to count, so that makes it 12. And we check to see if it's greater or equal to 15. No, it's not. So we output count, add 4 on to count. So count now equals 16. But because we're adding that on after the output, it's become 16. And now when we check, then count is now greater or equal to 15. So it never goes back into that loop. It now follows the yes part, which means we're stopping in this program. So our output is left as 0, 4, 8 and 12. It never got to display 16 as the count variable because it never re-entered that loop again. Let's have another look at a slightly different one. Here we've got 5, 10 and 3 as the options there. So we've got 5 as the starting value, 10 is our target, so greater or equal to 10, and our step is 3. So let's start off. So count starts off as 5. Then we go into the loop. Is that greater or equal to 10? No, it's not. So we're outputting count, which is 5, adding 3 on, so 5 becomes 8. Looping round, is 8 greater or equal to 10? No, it's not. So we output count, which is 8, adding 3 on, which is 11. Looping back round, is it greater? Yes, it is. So it drops out of the loop at that stage. So it never displays 11. It only displays 5 and 8. Now this makes sense when it's exceeding our target, but because we're saying greater or equal to as our target, then it also happens when we're just incrementing our steps by 1 each time and it lands on our target. So let's have a look. So slightly different one here. We're just using I as a variable. I don't particularly like using I as a variable, but I know some teachers do. We've only got the range, which is 3 here, and printing hello. So our start is 0, our step count is going to be 1 because it's assuming those. So it's only specifying 3 as our target, and it's greater or equal to 3. So let's have a look. I starts off as 0, and then it goes in and checks, is I greater or equal to 3? No, it's not. So output hello in this case rather than I. Then we're adding 1 onto I, so I becomes 1. Looping round, is I greater or equal to 3? No, it's not. So output hello. Add 1 on, so I becomes 2. Return to the loop, is I greater or equal to 3? No, it's not. So output becomes hello. Add 1 on, so that becomes 3. And then going round, it's met its target, so I is greater or equal to 3, so it drops out. So it's displayed 3 hellos, but the actual value of I, if we were displaying I instead of displaying print, it would have just displayed 0, 1 and 2. It wouldn't have displayed 3, because when it hit the target, it dropped out of the loop. So that's what you need to explain to students. Use a flowchart, use trace tables, show stepping through and adding on. But when it checks, when it meets that target, that's when it drops out. And that's why that stop is saying stop. It is not saying do another loop anyway. It's stopping it at that range. So when you are teaching students about the range function, first of all, teach them what the different parts of the range function do, the start, the end, and the step count. And then use simple code just to show the output. So don't try and do anything fancy inside that for loop, just display what count is or whatever it happens to be. And then use a flowchart and a trace table to step through the program so they understand what's actually happening, and they can see that when it hits that end, it doesn't continue on that flow and ever output it again. It's stopped at that point. And show lots of different examples as well. And ask your students to predict what's going to happen and explain it to you. So for instance, not just using numbers, but as we displayed with hello each time and things like that. So they can actually picture what's happening in the program a lot more. So you don't need to just say it's just one of those weird things that Python does. You can scrap that and you can now say Python exits the loop as soon as it reaches that target, and it doesn't repeat the loop, which will print out the final output. It's actually given them a reason of why it stops when it gets that target. Now, if you found this useful, then I do have a short course on Udemy called Computer Science Teacher's Guide Solving Python Errors, which helps with building confidence in debugging students' code. So you learn practical techniques to tackle common Python errors with ease and gaining the confidence to support your students' coding journeys without hesitating, so you can actually solve it for them. You can quickly diagnose and solve students' coding errors. You can empower students to actually debug them themselves, which saves you so much effort and time in the classroom. And you can just become this superbug hero in your students' eyes, so you can solve any problems that they've got, or actually ideally help them solve any problem that they come across as well. So if that sounds like it's a useful course for you, then check out my Udemy Computer Science Teacher's Guide Solving Python Errors. And hopefully I'll see you in another training session soon. Bye!